Welcome to part 3 of my Zenith Trans-Oceanic rebuild. It's been a while since I did part 2. I had a bit of a setback. I had a resistor blow up under the radio one day when it was set up like this. I turned it on one morning to get ready to do the alignment, and there was an explosion under the radio here. There's a big flash and a big pop and a bunch of smoke. And turned out a resistor blew, actually 2 of them blew, and took out 4 tubes with it. So I had to try to figure out what was wrong. I had to save up some money to buy some tubes, and I had other stuff to do this summer, like field day and some other stuff. So I'll turn it like this. This might work here. So the first resistor that blew up spectacularly was this 150 ohm resistor here, and actually replaced it, and I tried some other tubes in it for my good R600, and I blew those tubes out. So I had to save up money to buy tubes for 2 radios. I then noticed that this resistor here, this is 100 ohm, the first one was 150 ohm, was cracked and breaking, and when I touched it, it just broke right in half. So I replaced those, checked my voltages at the tube sockets. They seem pretty good. I put some tubes in it, and now it's working. In fact, the 1L6 I got is a solid state tube. One other thing that's different is I was told by the guy that sold me the power pack kit, I forget if that's the exact term, to take out C40. It wasn't in his instructions, and C40 went from here to somewhere else. I'm not exactly sure where right now. Is that in the picture? Great. It went from there to somewhere else. But so I took out C40. It wasn't hurting anything to have it in there, but it wasn't supposed to be in there. So due to the alignment, I have a signal generator hooked up to the 1L6, pin 6 for the hot, and pin 1 for the minus, I guess you call it. I got an alligator clip because this thing here, the spring went bad in it, so I got an alligator clip going to that. And then for the output, I got something hooked up to the speaker terminals. Now, I had been using a signal generator by B&K and a frequency counter to make sure I was dead on, but the signal generator was very weak at the higher frequencies. It may be working off of harmonics. So I found out that our club was somebody donated a spectrum analyzer. So I have a spectrum analyzer to use now. So this will generate the RF signal. I can control it, and it has an oscilloscope built in. So I'm going to tell you, I don't know a whole lot about these, but I know enough to do what I'm going to do today because I read the manual. I'm going to mention, this is called a Hewlett-Packard 8920A RF communications test set. And I'm going to say out loud where I set these things, just so that I know for future reference where I set it. Plus, if somebody happens to have a signal generator, they might get some knowledge out of this. So on the RF generator, I have it set to 455 kilohertz. The amplitude right now is at minus 85 dBm. The output is set to RF out. So here's the RF out, and down here it says RF out. And the AF generator's set to AM at 30%. I set a memory key so it'll switch between this and the scope. We'll go to the scope. Come on, light up. There we go. So the scope, the controller set to main. Their vertical divisions, I have to 200 microvolts, and the time division to 500 microseconds. And if somebody has better settings for me, please leave them in the comments. I would appreciate it. One thing I would prefer is that I just had a nice line that was still that I can measure as it goes up and down. So the instructions say to put the radio over metal plate, which I have. It said about the same distance from the radio. I don't think that's that necessary. And to use a isolation transformer. That's the word I was looking for. I got it plugged into an isolation transformer. Sorry, I'm not used to doing this. So it says to run the volume all the way up and to adjust A1 through A4. So these two coils are what I'm going to adjust. There's one in the top and one in the bottom. Here, and there's one in the top and one in the bottom. And you get to both of them from the top using this tool. You go part way in and make the adjustment. Then you go down a little more and make an adjustment. So bring the volume up to maximum. Speaker. I had to put the light on. I guess I could turn the light off. I have enough light over here. And I'll start making the adjustments. One, two, three, go back and do it again. One, two, three, and four. And that is the IF alignment. Now we'll move on to the RF alignment. Okay, now I'm going to move on to the RF alignment. And the first thing it says to align is A5, A6, and A7. This screw is A5, A6, and A7. And it also says to adjust A8. And A8 is a little screw right inside here. I got a little plastic tool there. It actually has a metal blade on the end of it that's just perfect for adjusting that. That's also known as a patter. And it says to fashion a loop of several turns of wire. It doesn't say exactly where to put it. That may not be enough loops, but that's what I have. Hooked up to the signal generator. I got the other end hooked up to ground. And I'm gonna, that's my finger, I'm gonna slide that under the radio. We're going to set the radio and the signal generator to 1600 kc and make the adjustments. Okay, I've got the RF generator set to 1600 kc. I have the amplitude at -45 dBm now. Here's the radio. You can hear the tone, but it's not on 1600. And I'm not going to put this at full volume because it's even more annoying at full volume here than it was when we did the IF. So I'll put that on 1600. Let's see if I can find the signal by turning the screw. I got a light off in here to make it the scope. Okay. And it says to go to 1400. 1400. Set this at 1400. Okay, it's at 1400. And do A6 and A7. You can hear a little bit of it there. So I'll try A6 and A7. Now with A6, I'm not hearing much difference. Tiny bit. Now I'll try A7. I'm going to go to where it was loud and try it. That's where it's loud. Now let me try it. Okay. Now it says set it to 600 kc and adjust the pattern. Adjust for maximum output while rocking the tuning gang through 600 kc signal. Not quite sure what they mean by that, but let's go to 600 kc. Seems to be way off. Maybe that's why we got to rock it. Oh, I wasn't showing you. There's 600 kc. I'm hearing the tone below it. Now I got it at full volume. Let me try turning up the amplitude a little bit. That's a -35. Rocking it through the oh wait, there it is. Go around and look at it from the other side. Okay, for the next part, it says set the scope and the radio to 7,800 kcs. We're on the next band up now. The band is known as 4 to 8 kilocycles. and so we have it at 7800, and it says high side of the signal generator to a 3-foot length of wire placed 1 foot from the extended wave rod. So here is the wave rod, and it is extended out across the room, and on the other side of the right side of the radio I have a 3-foot piece of wire paralleling it. That's what it says to do. And we're going to adjust now one of these 2 screws, one of those 2 screws, and one of those 2 screws. I can tell you exactly which one, but here is the schematic of the tuning gang. The only problem is it's upside down. So you got to hold it like this and then read all the numbers upside down, and they're all really tiny. So I have it on 7800 and it is off frequency. So I'm going to turn it up. These adjustments are called A9, A10, and A11. Adjust for maximum deflection. We'll go by sound. A9. I'm also looking at the scope. Okay, A10. Looks like it's this one. And A11 is this bottom one. Next, 4.2 and adjust A12. Okay, I got the signal generator set to 4200 kc, the radio set to 4200 kc, I have the tool into A12, and it's off frequency. Okay, that's A12. Okay, so off camera, I went back and readjusted A9, A10, and A11. And then I did A12 again. Now it says keep it at 4.2 megacycles and adjust A13 and A14 for maximum output, and then repeat. Okay. This is 13. Turn it up. Turn the scope on. This is A14 in the middle. That's me playing with the volume of the signal generator. You can actually hear through the signal generator too. Okay, I did that twice. Now we move on to 3.9 megacycles in the 2 to 4 megacycle band. Okay, now we're going to adjust A15, A16, and A17. I accidentally turned A15 earlier when I said I made an adjustment off camera because, like I said, when this thing's upside down, the numbers are so small you mix them up. So this is A15, this little screw. A16 this outside screw down here. There's the scope. I'm not seeing much difference as I turn it. I wish it wasn't jumping around. A17 is this other screw down here. Now we're at 2.1 megacycles, and we're going to adjust A18, A19, and A20. And then it says repeat the 19 and 20. Turn that up a little. I'll go to 20. And repeat. 18, 19, 20. Okay, that's that one. Okay, we're on 16 meters. At 17.8 megacycles. And we're going to adjust A21, A22, and A23. Adjust for maximum output while rocking the tuning gang through 17.8 megacycle signal. I went ahead and did one of these off camera because it took too long to find the sweet spot. And we're switching tools now. I'm now using this one with like a little tiny screwdriver in at the end, and this is the one I had been using. It's kind of a hex, a very skinny hex thing that did both the transformers and it did these lower coils. But now we're on to one that looks like a bit of a small screwdriver. So this was the first one, 21, and then now we'll go to 22. The scope is looking a lot smoother than it was. So now I'll go to 22. And 23. good. Bump a wire and it changes everything. Okay. Now with these higher bands, you're only making one adjustment right in the center of the dial. And I've noticed that accuracy is not one of the strong points of this radio in the higher bands. Like if you're just trying to tune WWV to 15, even after alignment, you will find that it's off a little bit. Alright, on to the next step. Okay, now we are on 19 meters at 15.2 megacycles. We're going to adjust A24, A25, and A26. So 3 down from the top. This appears to be way off frequency. Let's see if we can dial it in. Aha! Turn it up a little. Ooh, that looks good. Turn it down a little bit. That's what I like, nice and smooth. Now I'll go to the others. Okay, that is the 19 meter band. Okay, now we're on 25 meters at 11.8 megacycles, which again is the center of the tuning dial. I'm going to adjust A27, A28, and A29. So, and I turned down the amplitude a little bit. I just played that other one back and didn't realize how loud it was. Let's see here. Okay. First go. Not as steady, probably because I turned it down. Going through the coils, and I'm going to go through them again. Okay. Sorry for the jump in the film, but the camera phone I was using ran out of memory. But I was right at the end of that band anyway. Now we're going to move on to 31 meters, and the dial is set at 9.6 megacycles. The signal generator is at 9.6 megacycles. Or, megahertz. And we're going to adjust A30, 31, and 32. I got a little bit better light tonight, and I'll try not to get my hand in the way as much. So A30 is here, 31 is there, and 32 is here. Let's see. Oops. Coil. Now to 32. back to the first one because I don't hear it anymore. Okay, now I'll go to the other two. Last one again. Go back to that first one. There we go. Okay. That just about completes the RF alignment. There is one little footnote. After reinstalling chassis and cabinet, switch to the broadcast band and tune in a weak station near 1400 kc and retouch A7 for maximum volume. I don't know how I'm going to reach A7 once it's back in the cabinet. But we do have a station in town at 1390. It's only on during the day. It's only audible during the day. But it's nighttime now. Maybe I'll pick something else up around 1400. So that wraps up the alignment of the Zenith Trans-Oceanic R600. Next step is to put it back together.